All right, so we are gonna spend some time today. I have to do this as a recording, not as a stream. We will spend some time today practicing more with Brilliant. And the goal here is more of a review tool of the entire experience, right? Because Brilliant.org has done a major revamp recently where they now seem to be fully tutor driven. To be honest, I was a bit in a shock because I remember the Brilliant.org from the past was more like a lot of text and yes, interactive components, but there was still like a big component of text. And I so far I have the feeling everything that is now available is just it mostly looks like just Duolingo. So I don't know if that's the right thing to do, because while let's put it this way, while I think the type of content that you're consuming is for learning, that is, it's not so much relevant like the kind of content as in like the shape and form. It's important that you approach learning from a 360 perspective, right? So that you do all kinds of stuff, you practice, and we talked about this last time in one of the first videos where is the loop, right? It's 3 steps. Is you notice that you don't know something, then you go look for this something, and then you practice this something, and it's basically that like a loop, right? And you have to do that, like run that many times. That's what leads to learning a skill, right? It works both for physical skills, playing basketball, soccer, jiu-jitsu, but also sort of more mental skills, right? And more abstract skills like math and stuff. It's the same thing, right? Just run this loop. Just keep running this loop, because what you're doing is you're shaping the neural paths in your brain. And that's what knowing a skill or acquiring a skill really is, right? So yeah, let's get into this. All right, and I'm gonna turn the volume on because I want to hear the. But I'm only on my laptop, so hopefully the quality of the sound will come through cleanly. And we now go into trigonometry functions. What? Okay. So it seems like it's making me do a warm-up of what we did last time, right? So if the pattern continues, when will f of x next equal 7? Then it's 1, 2, 3, 1, 2, 3. But I don't see the little guy here now. It almost feels like the platform is forcing me to go through these. 4. A different periodic function g of x is shown below. If the pattern continues, what is g10? Okay, so it made me do a warm-up. I don't know why. But now let's go to the trigonometric functions, periodic phenomena, the period of a function.
You've seen how periodic functions repeat over time. Now let's measure that repetition. Place the points on the graph of the periodic function.
Place the points on the graph of the periodic function. Is as in where will they be? Like this?
Double check your work.
Oh, I think I made it too wide. Double check your work. Okay. Well, this is gonna go down all the way here. Okay. This is so simple, and I'm
Yeah, that's it.
okay.
Now find the next two inputs that give the output 5.
Find the next two inputs that give the output 5. Okay, so it's every 2, right? So this is 8, so it's going to be 10, and it's going to be 12, right? I think so.
Nailed it. Here's a different function this time.
All right.
Now think about it more generally.
If f of a equals 5, then what other inputs must also give the output 5? F of a plus something is always going to equal 5. Is 1, 2, 3, a plus 3. Right? And 6. Right?
Exactly. Here's the key. A periodic function f repeats its output values predictably. The period is the minimum distance p between inputs that must give the same output. The function below has period p equals 3. Do you see how that works?
Yes. Yes.
Awesome. Since you've got the hang of how the period works, are you ready to try it out on a problem?
What's an A problem? On a problem, okay. My English, oh god, sorry guys. Trying out on a problem. Yeah, sure. Let's go.
Let's put that to use. Give the period of the function.
That's not a problem. Repeats every 2, right? Oh, that's the trick. Oh, they're trying to trick me. That is, it's not every 2, it's every 4.
Right. Now evaluate the function beyond what's shown on the graph.
Okay. Now we need to find out if it's 20. So essentially, we know that it's a multiple of 4, right? Or because it's 4 times 5 is 20, right? So this means that it's going to be actually 6, right? What happens if can I check half the answer? No. Okay. But then if I know that f of 20 is 6, then 6 more basically means that we do a full cycle of 4, and then we're 2 more, so we're back as a multiple of 6. So we basically see here that, well, I don't know if that's good, yeah, well, it doesn't matter. We are reaching the peak, and then we are adding 6 more, right? Which is basically 4 more and 2 more, so we're always going to be at 3.
Well done. All right, now try transforming the function to get a specific period.
Oh, a period of 6. Okay. A period of 6.
Correct. Okay, last problem. The base function has a different period this time.
to have a period of 6. Okay, so but I mean it has a period of basically from peak to peak is just 3, right? Oh no, it's like it's 2. Now it will be 6, right?
The function f of x is periodic with period p equals 6. All inputs that are a distance of 6 apart must give the same output. Any final questions?
No.
Let's make sure it all clicked.
Skill check. A seismograph records the ground vibration shown. Wait, am I recording? Yeah. Okay, cool. A seismograph records the ground vibrations shown below. What is the period P of this signal? Well, we're like 3. It's 3, right? It's my internet bad, I think. Use the periodicity of the seismograph signal to evaluate F15 and F20. So F15 should essentially just, okay, so what's the period of that? The period of that is, the period of that function is 3, right? So 15 is a multiple of 3, so it's 5 times, and so it's gonna have 5, but essentially it's repeating the same exercises. To be honest, this time I'm not so happy about. And F20 is then just 5 more, right? So it's a peak and 5 more, so basically 3, 4, 5, so it's gonna be 3. Period 4. Again, these are easy topics, right? But what I'm thinking is horizontal shifts of periodic functions. Sine and cosine, right? Triangle trigonometry. I'm trying to, I think I should maybe, if I want to experience the tutor a bit more, and I probably have to level up I have to go to something more complex, just because I want to get more stack. You know what I mean? I want to get stack so that I can actually see how the tutor behaves. So maybe we should do something like more advanced math. Maybe we could do calculus, or we could do vectors, although vectors I have the feeling should be easy. We can do calculus, rate of change, tangents, maximum and minimum, critical points, although that's not too advanced either. I mean, let's see. I don't know. Let's see. We have to try. I want to try something a little more complex, just to see if we can get stuck in a nicer way. Because I want to use the tutor. You know what I mean? So far, it's not really something we're using. Okay, so now we have some text. This is an animation. Like Brilliant.org used to be way more text heavy. But anyway, you already know how to use math to model change. Let's start with finding the rate of change of water in a bottle. So the volume of water after t seconds is 50 times t. Okay. How much water is added to the bottle each second. Oh, okay, so looking at this specific graph, I guess. Oh, what? What? Oh, really? So the tutor... Oh, this makes no sense. Okay, so the tutor is not available in the advanced courses. They're still working on it. It says only on this, probably on the easy courses. Okay, no, I don't want to... I want to use the tutor. I probably have to wait a bit more then. I'm going to cancel the subscription. Okay, so it's only available for the... let's check. Maybe it's available in... They said in the coding stuff as well. But... Let's see. Thinking in Python. Again, it's very easy, right? Variables, blah, blah, blah. They should tell you if tutor is available.
Welcome to Thinking in Python.
Here it is.
You'll build up an app called Locked In, starting with the basics of storing information. A new user signed up and picked the username Chief of Stuff. Store it in a variable.
Chief of Stuff. Yeah, okay, but now here's where... Okay. So the three options that you're giving me are the same. They just have the text altered in terms of capitalization, some of them. And I know that it would be like technically good practice to choose something that is uniform. So we should normalize the usernames. Like, for example, transform them all in small case, right? To avoid people tricking others with numbers that are kind of like almost the same, but would have some camel case differences. But the exercise doesn't specify that. So what are you expecting, actually? It's funny how fucking slow this is, but it's because
normalization is a great idea in the real world, but Python treats every case change as a different string. Which option matches the user's input exactly?
Brother. Oh boy, that's a stupid thing, man. That's a stupid thing. Like, what? A new user sign up. They set their username to Chief of Staff. Store it in a variable. Yeah, but you're making me choose something which is just not like... This is ugly, brother. This is not good. It's like, yeah, sure, you're good, but like in the real world is okay, but like, but Python treats everything. Yeah, but and what? Like, I would still do normalization, right? But okay, I guess it's just the challenge here is like there's something missing, as in like they set the username to Chief of Staff, and they're like, fine, like that's not really how you would do this, but like I see that you want me to put B.
Spot on. Since Python sees those as three unique strings, matching the exact case is key. Ready to see it run?
Yeah, sure, but that's not the whole point, right? I mean, you're... Okay, whatever. How do I run it? How do I run it?
To run your code and see the output, just tap the check button. It executes your program line by line and displays the result.
What check button? Oh, these?
Now the same user has an age to save too.
Okay, the user has set their age to 23. Reflect that in the program. Oh, I get it. Okay, so it's basically like... Okay, age 23.
Exactly.
Oh, it runs like these. Okay, when you do check, it runs. Okay.
So, here's what you were doing. Variables store data, including strings, like Chief of Stuff, and numbers, like 23. In Python, a variable is set with an equal sign. The name is on the left, and the value is on the right. Does that make sense?
Yeah.
A password is just another string to save. The user picked $rupt.
Yeah, but you see, that is the... Like, I can... I can be an asshole and I spread some misinformation here. This is how brilliant teach you to process passwords. I'll take a screenshot. If they don't correct this by the end of this lesson, I'm actually gonna post this.
You got it.
Got it.
All right, last problem. This time, you'll set two variables at once, a number and a string.
Score the password with a number and a label, and label the password strength with a string. Score 12, strength medium. Okay.
Flawless. Nicely done. By setting variables, you've started working on a password strength feature. In this course, you'll learn programming concepts to upgrade Locked-in's app security step by step.
Okay.
Any final questions?
It's okay. Like, I know they're building it like these, but it's like...
Let's wrap up with a skill check.
Yeah, it's okay. I still think they should just mention that at least. What is the output of the program? Score 12. What is wrong with this program? Fix the program. Sorry. So many lessons. I don't have the patience to go through all the 70 lessons. Branching conditionals. I mean, these are all the basics of programming. I just want to do something more complex. What is these? No practice available. Okay. I want to do some more advanced stuff, but it turns out so Koji is not available in advanced stuff. I guess. I mean, I don't consider that advanced. Complex numbers, polynomials, equations and curves. Okay, maybe we could do equations and curves. I don't know, maybe this is a bit more interesting. Points on a curve. Maybe this one has the tutor as well. I just want to get stuck somewhere.
Welcome to Equations and Curves.
Okay, here it is.
In this course, you'll explore the deep connection between equations and their graphs. Complete the pair to make the equation true.
Okay, -1. So, okay, so essentially complete the pair xy to make the equation true. So if x is -1, then what is y? So y squared is 2. Well, y squared is, oh no, sorry, y squared is 0 because yeah, okay.
You got it.
Is a 3 exponent.
Now there are two values of y to find for the same equation.
Complete the pairs. Let's see. Let's pretend that I'm stuck. I know the answer to what I'm going to ask, okay? But I just want to see how the tutor reacts. How is it possible? Why are there two possible values for the equation to become true?
Great question. When we plug in x equals 0, we get y squared equals 1. What numbers can you multiply by themselves to get 1?
Okay. So, yeah, okay. It's not, yeah, it's good. It's good in the sense that it doesn't give you the answer, but it kind of gets you almost there, right? It says, what numbers can you multiply by themselves to get 1? Yeah, exactly. So, essentially, so one is going to be 1, and another one is going to be -1.
Yep. Same equation, but this time x is 1.
So x is 1. So x is 1. These, and what are the two values? So then 1 plus 1 is 2. Oh, we have that. That's a problem with this. This is a small screen, so I don't see the... yeah, so essentially 1 plus 1 is 2. So that's going to be... so y is basically going to be the square root of 2, right? But wait. So y squared equals 2, right? Yeah.
Yep, nice. One more. Try x equals 2.
So with x equals 2, now we, okay, so we're building the points here. Okay, I didn't notice that. So with x equals 2, 2 to the 3 is 8, so this is 9, and so this is basically the square root of 9, so it's basically 3 and minus 3.
That's right. Here's the idea. The graph of an equation is the collection of all points x, y which satisfy the equation. These points usually form a curve. Does that make sense?
Yes.
Now, select the point that's actually on this curve.
Okay, it's the absolute value of 3 times x minus 1. So we can just go by elimination, I guess. 3, so 3 times 1 minus 1 is 2, so this means this is not in the curve. Now this is 3 times minus 1 is the same as 3 times 1. Minus 1 is 2, so it's not, so it has to be this one.
Well done. Here's a different equation. Which point lies on its curve?
I mean, by elimination again, right? So it's going to be something minus 1, so and then square, right? So, and then actually, I'm just trying to do this on my head, so on a paper will be faster probably. But it's like, yeah, minus 2 minus 1 is minus 3. 3 squared is 9, depending on the sign. And then 1 this is definitely not this. 9 plus a quarter is now 5. So this would be 0, right? Because it's 1 minus 1 is 0. 0 squared is 0. And then 0 plus, okay, 0 plus 1 is definitely not that, so I would say this.
Right. And one more equation to check.
Select the point on the curve. X equals, okay, and then we just basically do 3 minus 1. 3 minus 1 is 2 squared. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. So that would be actually this one. So this is 0. Wait a second. X is 2, and this is 1. Definitely not the case. X is 1. This is minus 3, and minus 1. It's definitely not the case, because minus 3 and minus 1 is minus 4, which means definitely not the case. It's this one.
That's a perfect run. Here's the key. A point xy is on the curve of an equation if the equation is true when the point is plugged in. We say that xy is a solution to the equation. The point 8, 3 is on the curve because 8 equals 2 times 3 minus 1 squared. Any last questions?
No.
Now, let's quickly check your understanding.
Okay, we're going to wrap it up here. I'm going to do this test and then wrap it up. I think, again, we had that. Okay, so there was this moment where I asked it why, and it didn't do a terrible job. It actually did a good job, I think. But okay, so what do we have here? So we have 3, and then what's y, right? So 3 squared is 9. 3 squared is 9, and so 25 minus 9 is 16. And then it's 4, right? Cool. So here, select the point on the curve. Which one it is? Okay, so we are looking at 10. And so essentially, basically, it's, let's look at y squared is 9. So that's 9, and that's 1 is on 0. So this is not the case. 3 squared is 9. Yes, this is the case. Cool. And find a point in the curve. So if x is 2, 2 times 2 times 2 is 8, minus 7 is 1. Oh, sorry. Here. Okay, we'll wrap it up here, guys. Again, it's okay. I just wish it was in the more crazy stuff. Crazy. I mean, it's not really crazy, but like I went to basically the calculus stuff, and it was not there. Mind-bending math. Is it in the puzzles, or is it in geometric thinking, for example? I love geometry, so maybe it's there. No, it's not there. Okay, so it's not available in all the courses, but it's coming soon. It's all right. We'll wrap it up here, guys. See you tomorrow.